So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as Database Management System. So what type of database we are going to use in GIS? How do we utilize it for the retrieval? How do we utilize it for the query purpose? So this all we are going to discuss today. So let us start with this contents today. So what are the contents today we'll get to know. So today's content is about introduction to DBMS, role of DBMS in GIS, data storage and GIS, and data integrity and validation. And we have data query, retrieval, spatial analysis and processing, spatial database management system. So these are all related to the GIS database, because whatever data we feed in GIS, how we are going to utilize it for the retrieval purpose, or if anything is required for the output purpose, if we need any kind of results, so we need to go through this database, because all the data will feed in the database itself. Then later whatever query we do, that query can be easily, we can get the results of that output. So let us start with the introduction to DBMS. This DBMS is related to the GIS, like whatever data we are utilizing. So till now, in the previous lectures, we have discussed about the spatial data and the non-spatial data, and types of raster data, types of vector data. So these all types of data, when we use the software, these all data will be saved in the DBMS, that is database, where the database will manage the data whenever it is required for the any kind of results we need, right? So database in GIS, so GIS, Geographical Information System, basically it's a database management system. Also we can call it as decision support system. So we also call this GIS as DSS, that is decision support system. Why? Because it gives us the information, help us to give a proper decision, to take a final decision. For example, if in a city, some city has to be planned, so decision makers and the planners are totally dependent on this spatial and non-spatial information and the surroundings around that. So this all information can be easily get through this GIS process. So once the data is fed in the software, once the data is fed in the DBMS, then only we are able to retrieve the data, we are able to get a decision, and that's how we call this GIS also decision support system, because it's such a database which will help us to take a decision in any other requirements whenever we need, right? So DBMS plays a crucial role in the managing, storing, querying spatial and non-spatial data. So I hope you remember spatial and non-spatial data. It's like about the data the spatial data is totally about the data what you see around you. So we have lot of time we have discussed about the spatial data. So whatever we see around us, whatever features, whatever physical features we see around us, that all comes under the spatial data information, right? And the non-spatial data information is the data which is giving the information about the spatial is called as non-spatial information. So this all information is stored before itself in the DBMS, the database of the GIS, which will help us to manage the data at any point of time. And it helps us to, it is very much useful in the various fields like disaster management, like forestry, resources, water resource, because once you feed this all information in the DBMS of GIS, it will help you to give the proper query, and it will help you to take a proper decision for the further any type of construction activities which is going to happen in such kind of city or such kind of areas. Okay, so GIS integrates the spatial data with attribute data and robust DBMS, and it supports the integration by providing the necessary tools and the functionality to the users. Okay, now what is the role of DBMS in GIS? So what is GIS? Basically, if you remember, GIS is about the storing, manipulating, analyzing, and any kind of editing. This all information, wherever we can do that, all combines together, and it's a set of hardware and software where you can use the tools and where you can use the data for the utilization of any kinds of results which you are going to acquire. So this all data are fed with the help of the hardware and the software. We need the hardware and the software both to feed this kind of information in the system. So why we need hardware? Because this GIS hardware needs a software to install the software. We need a hardware setup where the data can be fed properly. Now, what is the role of DBMS in GIS? Data storage and management. So it basically helps us in storing the data and management. So DBMS stores the spatial data, which includes the geographic coordinates, geometries like point, lines and polygons, and the spatial relationship. So what is spatial relationship? I'll tell you. So first of all, includes the geographic coordinates. What are the geographic coordinates we see in spatial data? So geographical coordinates is about the latitude and longitude. Okay, the coordinates which we assign to a map, that all comes under the geographic coordinates, and the geometries like all this points, line and polygons. Points, line and polygons. So what are these things? If you remember, we have discussed in a lot of times in the previous lectures. So these are all shape files. Okay, shape files, and it is also known as the vector data. So it is points, line and polygon are the soft copy of the raster, we can say, and we can say it's a shape file and as well as a vector data, which will help us to take a further decision. Any type of data which is on the raster format that is converted to the soft copy of that raster, that comes under we call it as vector data, and that is a digital data, that too, and it has a shape along with the files. Why we call it as, every time I'll explain in most of the lectures, that shape file means what? Shape file is what? Point, line, polygon. So each point, when we put a point, so this point is called as the spatial. Okay, so now if you are assigning some information to this point, then it becomes the non-spatial. Okay, so the points will carry, the shapefile will carry both spatial and non-spatial information. That's why along with the shape, it carries the non-spatial information, which is called as the shapefiles. And same the way like lines we have, same the way like polygons we have, and the spatial relationship. So what is a spatial relationship? Spatial relationship means topology. Okay, topology. So what is topology? It's a geometric relationship between one entity and the other entity. So it will help us to know the relationship between one polygon and the other polygon, and this will help us to just let us know the geometry of that particular area, whichever we are going to demarcate. So DBMS also manages attribute data, which describes the properties or characteristics of spatial features. So also describes the attribute data. What is attribute data? So when every time we talk about this non-spatial, what is non-spatial? Non-spatial is about the data about the spatial, which gives the information about the spatial, is called as non-spatial, and attribute data is the other name of the non-spatial. Okay, so attribute data is the other name of the non-spatial, means when you talk about the tables, when you talk about the population density, when you talk about the land use types, soil types. So when we talk about this kind of data, which is in the form of table, in the form of a chart, or any information which is fed in the table, that all comes under the attribute data. So attribute data is also known as the non-spatial data. And the other name of non-spatial data is also called as aspatial. We just call it as aspatial. Okay. So as aspatial, spatial, non-spatial, this all information comes under this attribute data. So this DBMS will manage this attribute data to store a lot of information about all the spatial information, which will help us to in the retrieval. When you do a query, it will help us in the retrieval. So once you feed the information about the spatial and non-spatial, just like a Google Earth or Google Map. So once you type any information that so and so query you need so and so city, so it will give you the spatial information as well as non-spatial information at a time, that which will help us to know the current situation of that area. Right now, DBMS, this is how it is working, like applications, and it helps in other DBMS uses. So it will like define, record, query, it can update, it can manage the data and storage. Like it has a different types of DBMS. Later further, if you see relational, hierarchy, files, DBMS, and you have an object database. So this is how the database management system works in the GIS process, which will help you to update the data, query the data, record the data, manage the data. So once you feed this all information in the DBMS, it will help us to finally, whenever you need to define, whenever you need to record, whenever you need to do a query, you need to update the information, manage the data, that all information can be done with the help of this DBMS process. Okay, so now the second role of DBMS in GIS is data integrity and validation. So what is data integrity and validation? It enforces rules to maintain the accuracy, consistency of data, such as ensuring that spatial data. Okay, it helps us to maintain the accuracy. So usually it will help you to maintain the accuracy once the data is fed in the DBMS. So accuracy will be maintained and consistency of the data will be maintained, and it will assure the spatial data adheres to certain geographic constraints. Okay, so ensures that spatial and attribute data conform to predefined formats and the rules. Right. So basically, data integrity and validation, data integrity, reliability of the information regarding the physical and logical validity, and data quality, how reliable information is to serve some intended purpose. That will help us to, DBMS will help us in this data quality and the integrity in the GIS. Now, data query and retrieval. So how do we call this data query and retrieval? Means it allows us for querying the spatial data. Okay, so every time if you see, we are talking about the spatial data and non-spatial data or attribute data. Okay, it allows us to querying the spatial data based on location, distance, or spatial relationships. Okay, location, distance, or spatial relationships. It will help us in the location, means it will tell us about the locations, it will tell us about the distance or spatial relations. For example, if you do a query in Google, okay, let us do a query in Google. So what type of query, like we'll type here Secunderabad city. Secunderabad city. So Dundigal to Secunderabad. So immediately if you type in Google, what you will get? Finally, you will get the location, you'll get the distance, and you'll get the spatial relationships, right? So this all information you'll get to know once you do query in this Google or any. If it has a database with the system, it will give you the location immediately, it will give you the distance immediately, it will give you the relationships between the spatial data there. And it will enable the querying of non-spatial data based on the attributes. For example, finding all parcels of land with the specific land use type. So it will enable the query of the non-spatial data. It is based on the attributes. So what are the attributes? It is based on that. It will help us to find out the parcels. It will help us to find out the land and specific land use type in that area purpose. Okay. Next, this is how the data query help us, right? So these are the data which is having the spatial and non-spatial, spatial and non-spatial. So when you do, when it is linked to the web server, so like it is linked to the map server, web server, and Google Map server, then spatial and attribute data is just linked with this. And finally, once you do the query, it will give you the, once you do the query, it will give you the answer. Okay, so this is how the DBMS will work to query the information, and finally we get the answers from this all web service, and any kind of data whenever we require. The retrieval is very much easy when you have the data in the DBMS. Okay, now this is one more type of query we do in GIS. So this is about the GIS software when we have discussed in the previous lectures also. This is a software called as ArcGIS, right? So in this ArcGIS, you can see this is spatial and this is non-spatial. Okay, So why non-spatial? This is having the information, you can see here it has information of polygon. You can see in this polygon, this blue color line is selected. Okay, so when the blue color line is selected, that means what we have done the query, right? So in the query, just we need this all information which is linked to the spatial. So once you do the query by attributes, once you select the attributes, so here the attributes are selected. So what are the attributes here? So attribute is a non-spatial, okay, non-spatial. So once you do the query by the attribute, the selection is done. So from layer 1 join layer 2, where condition or order by the group attribute. So once this is the query we do in the GIS process, so immediately what happens, it will just get selected and it will show us that which are the attributes which are selected and which are the non-spatial information to be has to be given the results. So query is by location. If you want to do the query, want to select the features from layer 1 that intersect are contained by the touch the boundary of the features in layer 2. So these queries can be done by the attributes, it can be done by the locations. So locations by selection we can do, and you can do the query by the attributes also by selection. This type of queries we do in the GIS process when the data is fed in the DBMS. So database management will help us to do these all queries. Once the data is not available, the query is not possible. So spatial analysis and processing. What is spatial analysis and processing? It supports the complex spatial operations like buffering, overlay, and proximity analysis. So spatial analysis and processing, in the previous lectures also we have seen many times this word called as buffering, overlay, proximity analysis. So what is buffering? How we can do the spatial analysis in the buffering? So buffering means always it is possible with the vector or raster. We can do with vector and raster. So generally we do with the vector data. So in the vector data we have buffering like point, we have line, we have polygon. Okay, so if this is the point, if I want this buffer, so what will be the buffer? This is the buffer for the point. Okay, so what is the buffer here? Here buffer will be 5 kilometers. So like this is 5 kilometer buffer, we say. Like that, if for line, if it is there, this is the line. So if I want to create a buffer of the line, so line will be created like this. Like this buffer will be created around the line. So this is the buffer for 10 kilometers buffer, we can say. So how much area we want to show in the, to be considered can be shown with the help of the buffering system, right? So here we have for the line, same thing with the polygon. Suppose this is the polygon. If you want to show the buffer of 5 kilometers again, so this will be created around this polygon, which will be of 5 kilometers buffer. This is how we can do the spatial analysis in the GIS with the help of the DBMS. Now overlay analysis, many times we have seen in GIS, overlay analysis is very important analysis, and it is very much helpful for getting a better result. So overlay analysis is what? So the geometries will be aligned together, so it will match the other geometry. Suppose there is one layer and the other layer is aligned, the third layer is aligned, the fourth layer is aligned. So like this, the layers are aligned one over the other. This is layer 1, layer 2, layer 3, 4, 5. So total 5 layers are there. So once you run this overlay process, what happens? The overlay process will merge this all information to each other. Suppose one information in a single map, you have the information of point here, there is a building here, there is a road here. Okay, you have a water body here, you have a tree here. So there is one more building here. So these are the all information you can see in a single map. So this all information, if you shift to the single layers, like building you shift to the first layer, tree you shift to the second layer, water body you shift to the third layer, roads you shift to the fifth layers, and later you just align that all layers together. Then the overlay will be possible, and the overlay is only possible. Just remember, overlay is only possible when the data is georeferenced. Once the data is not georeferenced, the overlay is not at all possible. So once the data is georeferenced, that analysis we can do in GIS process, that data will be overlaid automatically, and you can see all the layers are aligned together and it will form a single layer again. So later if you want to separate these layers again, you can separate based on this overlay process, right? Now uses indexing and the other techniques to efficiently perform the spatial queries and the analysis. It will help us to use in indexing the other techniques efficiently and perform the spatial queries and analysis in the process. So this is how the spatial query we do in GIS. Here you can see here spatial query in GIS. You can see here these are all the data which are selected. Okay, selected. So this data, if you do want this data, so it will be selected and it will give the information like this in the form of table. It will show you in the form of table like this is the point number 1, point 2, point 3, point 4. So like that the information will be given in the GIS process. Okay, so this will be the output. Now spatial database management system. Now we have one more name for it, that is called as spatial database management system. We call it as SDMS. SDMS is what? Spatial database management system. So spatial database management system is an extension of conventional database management system. So it's extension of DBMS. DBMS, when you call it as SDBMS, it's extension of DBMS. So it's like a basic data type such as integers and real numbers are extended into the spatial data types, such as points, lines and polygons in the spatial structures are used in the spatial database. So why we call it a spatial database management system? Because it is totally related to the spatial data. Spatial data will help us in all the information will be fed in this DBMS format to get the proper information about it. So operations constitute the capabilities that manipulate the data structures. It will help us to constitute the capabilities that will help you to manipulate different kinds of data. Manipulation means you can overlay, you can just use this clip process, you can use the merge process, you can use the union process. These all manipulations can be done. How much data you want to keep, we can keep. The deletion is possible, update is possible. That all comes under the manipulation process. And as such, when the sequenced into the operational workflow in the specific ways, so to generate the information from the data, one might say the new relationship constitute the information from the data. So different data model designs results in the different combination of structures, operations and rules. So this combines into the various SDBMS, that is spatial database management system products. So different kinds of models like we use in GIS, like designs results in different combinations of structures, different combinations of operations, different rules we use topology rules, and this all combined together will makes a spatial database management system of system products. Okay, so spatial database management system, both software and hardware. So subcomponents are organized data for both software and hardware, as we have discussed in the previous slides also. Spatial database management system, it will be along with the software as well as with the hardware. Hardware we need for the installation of the software, and software we need for the SDBMS, that is for feeding the database, manage the database in the system. And subcomponents organize the data for enumerating and querying databases. Enumerating and querying the databases wherever the data is required for enumeration, and wherever a query is done, that all required in the database purpose. So conducting spatial analysis and creating the map will also help us. Conducting the spatial analysis, just now we have discussed about the overlay operation and different kinds of buffering system and proximity analysis, spatial analysis, that all comes under the conduction of this spatial analysis and creating the map. So based on the requirement purpose, creating the map means based on the project where it is located, where is the site is located, what is the requirement, the creation of the map can be done with the help of the spatial database management system. So visualization within an integrated manner for managing the large data stores. So database management system is a subset of larger category of technology called data management technology. So data management is a subset of a larger category that is called as data management technology, and data are managed by two files. First of all, the data is managed by two types of computer based file. What are the two types of computer based files? Are physical files and you have a logical files. So when you're talking about the hardware and the software of the computer system, the setup of the GIS process, so in that we have two types of computer based where the data is managed. So the two types of data where the database is managed is called as physical files and the logical files. Now what is physical file and what is the logical file? So a physical file is a location, it's a file is a collection of records which is managed by the operating system. Okay. Physical file, it's a collection of records. So whatever records, we keep it in the computer setup, computer system. So that will be managed by the operating system software as stored on the disk. So operating system, that is about the Windows, we talk about which Windows, Windows 10, Windows 7, Windows 11, based on that which kind of operating system is there which is compatible with the software. So that will help us in this to manage this data in the physical file. So physical file is managed by the computer system, a data file being different than the database. And the logical file is a collection of records. What is logical file? It's a collection of records which is managed by the application software. So there are two database in the system where the file is managed. For one thing is like physical file. So the physical file, it is a collection of the records which like operating system will manage, like Windows 7 or 8 or 9, Windows 10 or Windows 11, that will be managed by the computer system software. Whereas logical file, it's a collection of records which is managed by the application software. So what is the application software here? So application software here is like ArcGIS is application. Okay, application. ArcGIS, we have QGIS, we have WebGIS, okay, we have ArcView. So these are all softwares which will help us in the application software. These are all application software which will help us to record and manage the data in the logical file. So most fundamentally, the database management system software. So many logical files can be combined into the physical file. So many of the logical files we can just combine it and we can make it as a physical file. So what type of files we have here? We have a physical file, we have a logical file. So physical file is managed by the operating system, whereas the logical file is managed by the application software. So operating system means like Windows, we talk about the Windows, and when we are talking about the logical file, application software, when we are talking about, it is about the software where it is installed in the setup, a GIS setup. Okay. Now what are the different sources we see in the GIS of the spatial data? What are the different sources we see? Spatial data can be collected in the house or purchased from the commercial data provider. So there are different sources where you can receive the data for the spatial data sources. So once you see the geocode about the address, customer data, location of the assets, this all information, customer list and the location of the assets can be found out from the geocoding. So this all information you can get through the organizations where you can find out this customer information or the data about the assets and the locations in the what you can say cadastral locations, cadastral maps or central survey office, you can get to know. And then you have this load from the remotely sensed data, satellite imagery, GPS, aerial photography. This all information we get through the satellites, aerial photos like photogrammetry. We use it from the GPS system and then it is loaded in the DBMS, right? Later, what you have here is map data, roads, passes, this all information again through the digitizing process. We just digitizing process in the software. So this is the like DBMS. We just load all the information in this system for the getting the further information, or we can say this as DBMS further getting the spatial information in the software. So management of GIS data consists of storing a variety of data categorized under two types. So what are the data which is managed which is categorized in two types is entity, that is spatial, and attribute or spatial data. Entity and the attribute. Entity is the spatial when you're talking about point, line and polygon. What is attribute when you're talking about the tables, about the charts, or about the information about the spatial, that all comes under the attribute, and it is also known as spatial. In a way that permits us to retrieve or display any combinations of these data after analysis and manipulation. Now, in order to perform these operations, the computer is able to store, locate, retrieve, and analyze and manipulate. So, how it is possible? When the database is already stored and when it is in a proper location, then only this retrieval and analyze and the manipulation is possible. So, the raw data is derived from the number of sources by using the representational files and structures. In other words, each graphical identity must be stored explicitly and along with this attribute so that we can retrieve and select and the correct combinations of the entity. So once the attributes are fed properly, when the data is fed properly, then only we are able to retrieve the data and select the correct combinations of the entities like spatial and non-spatial and attributes in the reasonable time. So GIS database comprise spatial or entity and graphical database, non-spatial or attribute database, and it's a linkage of mechanisms for the different topology. So all the database which is fed in the software, it will help us to find out, or it will help us to show you the mechanism of the linkage of the topology. Topology means it's the linkage between one entity and the other entity. For example, you have a polygon. So the polygon will be like you have a point in a polygon. There are different topology rules. So point in a polygon, you have a line in a polygon, and how these entities are mapping together, or there should not be any overlap or something like overshoot, undershoot, that should be free from the errors. So that all topology should be built in such a way that once the data is fed in the software accurately, then only this topology mechanism is possible. So to show the relationship between the spatial and attribute data and the further analysis. So an entity, a point, line or area has both spatial and attribute data to describe it, and spatial data can be known as where things are, data and attribute data and what things are. So it will help you to know the things where things are, and the data about the attribute data, what, where and what. It will tell you about the where is the information and what is the information. So location it will tell you, and what is the information once you have this spatial data. Okay. So for example, a point entity, the Charminar, a monument in the Hyderabad, has a reference in terms of latitude and longitude. So if you are talking about the entity, this is point entity, the Charminar it's a point entity. So we are showing the point entity is a spatial again. Okay. So we are assigning the information. The non-spatial is here is what? Non-spatial is Charminar. So point entity is a spatial, non-spatial is Charminar. So it's a monument. So both the information is having in the form of, and it has having a latitude and longitude reference terms. To accompany this, there would be an attribute data about the nature of remote sensing and GIS, the real world features that the point represents. So entity type is a point spatial data or longitude and latitude. Attribute data is a monument and chart. Okay. So non-spatial data, how that you understood, right? Spatial is what? The point is the entity, and non-spatial is the name, the Charminar, what you're talking about, that is called as non-spatial entity. So non-spatial data can be stored in any conventional databases, where spatial data, which is a dominant data. Okay. So in GIS should have the databases which is capable of handling the spatial data, right? So this is about the information of DBMS and SDBMS, which will help you to get the information whenever required. It will help you to do the query. It will give you the retrieval of the data. So data should be fed properly. Once the point is fed, definitely the non-spatial information should be fed. Then only you can just do the query. With the help of that query, you can get both the information, where is the location and what is the place. Like here you have seen where the things are, where exactly location and what things are. About the things and location of the things will help us to give the information. So this is the very important thing in the GIS process, that DBMS should be stored properly, and it will help us to get the results easily once the data is fed in accurately in the GIS database management system. Okay, so these are the references you can just go through to find out the more content about the database management system. Just go through this MG book, and online just you can go through this NPTEL links where you can just find out the more content about this DBMS process. Okay, so that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.